It's finally time to start learning about lifetimes, and lifetimes are lifetimes. So this is how long a variable lives, and this is really interesting. It some people hate learning about lifetimes, hate having to use them. You can you can avoid them as basically you can avoid them as long as you want until you decide you want to start using things like stirs in structs and so on. But we'll start really slowly, and I just want to show you one thing in the beginning. The stir type, looks like that. There are actually two kinds. You have the regular one, which is called or not the regular one, the one that is a reference to like a string, and then it looks like that. And then you also have this, and it's called a static string, and we've been using these all the time actually. So when you say let x equals hello there, then that is a static string. And static, we saw the static keyword before. It's not the same, but here it's well, it kind of is. It's the static lifetime. So it's a lifetime. It lives as long as the program. So it it stays there. It's inside the binary. It's not going to die anywhere. So that is what static is. And if you so we can say let x a reference to string slice, that's what you call them. Hello there, and this is so this is the static stir that we just looked at. And so you can actually say you can do that as well. You can declare it by saying, hey, by the way, it has a static lifetime, and this tick is what you use to describe a lifetime. And this static is a special lifetime. It's besides static, when you use lifetimes, you write your own name. So you can usually you see something like an A. But so an interesting thing here is we're not going to get too into this, but let's say we want to say, hey, I want this to have a lifetime, and I'm going to call it A. Rust is actually not going to let you. It's going to say, hey, you didn't tell me what this A lifetime is about, so you can't just start doing that. But static is a special lifetime name that's always there, and it means that it lasts for the whole program. So that is the first thing to know about stirs is that there are those two ways to get one. And I'm going to show a small example here. So my stir, and we have this. And let's say print line, and we're just going to print it like that. So that's what that function does. And then down here, let's create a string. And this is about the relationship between strings and stirs. So we have a string from I am a string, and so you can see we are creating a string from a stir. That's what this is. And then we have a full string, but then we say print stir, and we throw a reference to that in there. And this is actually going to work because like you can actually write this, and it'll also take it. So this is a reference to a string, but it also has the same functionality as a stir. And there's a reason for that that we won't look at yet. But I just want to. This is the reason why. So there's a trait called deref, and deref is the thing that lets you use a star. Let's see, where's a star in there? Well, we've been dereferencing numbers before. Star with the opposite of an ampersand. And so here's the important part. If you implement deref, you inherit all of stir's methods. So basically, you can Rust can treat it if you pass it in as a reference, then Rust can treat it as a stir. So that's why you see them together so much. And this is the usual way you will write something that takes a reference to a string, because this will let you take both a reference to a string and also just a stir by itself. So you can pass that in. So that'll work. But then if you say, hey, this has to be an actual reference to a string, then let's comment this out. Then this is not going to work, because it is a static stir with see, there you go, with a static lifetime. It's not connected to any strings. So when you're declaring something and you want to take maybe a string and maybe a stir, it's better to do that, and then you can pass in both of them. So that is a quick introduction, and then in the next video we're going to start learning about what that a business is, and how to declare your own lifetimes, and let Rust know that you were giving it a variable that is going to live as long as it needs to. And it's quite similar to generics. It's like guaranteeing you're not changing anything, you're not changing any lifetimes, you're not making things live longer or shorter. You're just telling Rust, I'm going to give you something that is that you can use, and so it's just informing the compiler. So we'll look at that in the next video.